Welcome back for lesson 76. We're talking about how to find the volume of prisms and cylinders. And your objective is here, so let's go ahead and get started. The way you find a volume of a prism or a cylinder is the area of the base times the height. Okay, so now a prism might be a rectangular prism. Okay, might look something like this. Okay, a cylinder would be something that's got a circular base to it. Okay, something like that. Okay, rough sketch. Alright, but that's what a prism or a cylinder is. Okay, now prisms can have different bases. We could have a square base, a rectangle base, a triangle base, a trapezoid base, whatever it is. Okay, but it's got to be a 3D object. Alright, now let's go ahead and get started. Okay, example 1 says to sketch the base of this triangular prism and find the volume. So it's a triangular prism because the base is a triangle. Okay, so anytime if you were trying to figure out what shape the base is, because you see on this prism we've got rectangles, okay, and triangles, then the base is always whatever the prism is named. So triangular prism. So if I want to sketch the base, I'm going to go ahead and sketch this base right here. Okay, we got a right angle here, and this side is 8 centimeters by 6 centimeters. And if I look down here at the bottom, we can tell that this slant side should be 10, this side right here, because they should match up. Okay, so there's the base. Now if I want to find the volume, okay, that's the area of the base times the height. So for the area of the base, I have to find the area of this triangle. Okay? So the area of the triangle times the height. That's how we're going to find the volume. Well, to find the area of the triangle, I know that that formula is 1/2 times the base of the triangle times the height of the triangle. Okay, so that's why they had to sketch this over here, so we can just see what those are. Well, the base of this triangle is right here. Okay? Because the base and the height of a right triangle are always the ones that make the right angle. So the base is 6 and the height is 8. So we're going to take 1/2 times the base 6 times the height, which is 8. Well, 1/2 of 6 is 3, and 3 times 8 is 24. So the area of the triangle is 24 centimeters squared. And we're going to multiply that by the height of the prism now. The height of the prism is right here. It is 12 centimeters tall. Okay, so we're going to take 24 times 12. 4 times 2 is 8. 2 times 2 is 4. With a 0, we get a 4 and a 2. And it's 288. And we do volume, it's always centimeters cubed, or whatever the label is, cubed. And here's why. We got centimeters squared, so there's 2 centimeters, and another centimeter, 3 total. So centimeters cubed for the volume of that prism. Again, we took the area of the base, so the area of the triangle times the height. Alright, let's move on to the next example. Example 2 says a AA battery is about 50 millimeters long and has a diameter of about 14 millimeters. We want to find the approximate volume of the AA battery, and we're going to use this for pi. Okay, so again, the volume is the area of the base times the height. Okay? Well, my base in this case, if I look, anytime, this is a cylinder right here, and a cylinder, the base is always the circle. Okay, so we're going to find the area of the circle times the height. Okay, so if I sketch the circular base here, looks like this, and it says the diameter is 14 millimeters. Okay, well the area of a circle is pi times radius squared. Okay, so pi times radius squared, we're going to use 22 over 7 for pi, it says. So I'm going to put 22 over 7 times radius squared. If my diameter is 14, then my radius is 7. So we'll multiply it by 7 squared. So I'm going to take 22 over 7 times 7 squared is 49. And that's the same as 49 over 1. Okay? The reason why I want to do that is so I can simplify these. Okay, well 7 goes into 49 7 times. So on top I've got 22 times 7. Well, 2 times 7 is 14. And 2 times 7 is 14 plus 1 is 15. So that's 154 millimeters squared. Okay, now times the height. Well, for the height of this, we're going to pretend like we're going to take this and stand it up, okay, on its base. So then the height is the 50 millimeters. So we're going to take 154 times 50. And we put our 0 there because it ends in a 0. And 4 times 5 is 20. Carry the 2. 5 times 5 is 25. Plus 2 is 27. Carry the 2. And 5 times 1 is 5. Plus 2 is 7. So that is 7,700 millimeters cubed. This is the approximate volume of that AA battery. Alright, now let's go ahead and move on to our next example. Okay, example 3 says the figure shows a triangle that is the base of a triangular prism. The height of the prism is 10 centimeters, and we want to sketch the prism and then find its volume. Well, here is the original problem. Okay, says that this figure shows the base of a triangular prism. Here's our sketch. Okay, so I went ahead and copied this picture down and sketched it for you. So our base is here, and to make a triangular prism, okay, we go like this. Now again, if I wanted to sketch this, okay, I'm not a very good sketcher, but we could use this, okay, to sketch our triangular prism here. And then we would just have to have some lines that go like this, and that would be our triangular prism again. Okay, and it would look pretty much like this picture, but again, I'm not as good of a drawer, so I took it and copied it down for you. So remember, the volume of any prism is the area of the base times the height. So we want to find the area of the base, which is this triangle right here. Okay, so we got a triangle that's got a height of 4 and a base of 6 centimeters. So the area of the triangle is 1/2 of the base times the triangle, which is 6, times the height of the triangle, which is 4. Well, 6 times 4 is 24, and half of that is 12. So the area of our base is 12 centimeters. Times the height. Well, the height is going to be, if we stood this pyramid or this prism on one of its bases, okay, on one of the triangles, the height would be right here, this 10 centimeters. So it's going to be times 10 centimeters. And 12 centimeters squared times 10 centimeters gives me 120 centimeters cubed for the volume of our shape. Okay, and we got one last example for you, then we'll be done. Example 4 says Buster has 2 empty cylindrical soup cans. Okay, so like Campbell's chicken noodle soup. The smaller can is 2 inches in diameter and 3 inches high. And the dimensions of the larger can are twice the dimensions of the smaller can. Okay, so what I'm going to do is draw out these 2 cans here. So we're going to have a cylindrical can here. Okay, and then another cylindrical can. Sorry, my pen's a little off, so my drawing's a little off too, but close enough, you get the idea. Okay, and it says the smaller can is 2 inches in diameter, so our circle has a 2-inch diameter, and it is 3 inches high. And the other can says the dimensions are twice the dimensions of the smaller can, so that means that the diameter is 2 times this one, which is 4 inches, and the height is 2 times the 3 inches, so 6 inches. And we want to find first the volume of both cans. So we want to find the volume of the small can and the large can. So again, it's the area of the base times the height. And for the large can, we're going to do the same thing, the area of the base times the height to figure out their volumes. Well, for this area of the circle, okay, it says find it in terms of pi, okay? So our area formula is pi times the radius squared. So we're going to leave it in terms of pi, and our radius, if the diameter is 2 inches, then the radius is 1 inch, so times 1 squared. Well, 1 squared is 1. So basically, the volume of the smaller can is 1 times pi, okay, or that's the area of the base, so 1 times pi inches squared times the height, which is 3. Well, 1 times pi times 3 is just 3 times pi inches cubed, okay? So we're going to multiply the number parts and then put pi after it. So the volume of the smaller can is 3 pi inches cubed. And for the larger can, again, we're going to take area equals pi times radius squared. So we're going to have pi times the radius is 2. Well, 2 squared is 4. So we're going to get pi times 4. And the area of the base is 4 pi inches squared. We're going to multiply that by the height, which is 6. Okay, well, 6 times 4 is 24 pi inches cubed. Okay? For part B, it asks us what the scale factor from the smaller can to the larger can is. Well, this says the dimensions of the larger can are twice the dimensions of the smaller can, so that means the scale factor is 2. Okay, because the larger can is twice as big as the smaller can. So if we take the smaller can, the first one, times 2, that will give us the larger can. Then it says if the smaller can is filled with water and the contents are poured into the larger can and the process is repeated until the big can is full, how many small cans of water will be used to fill the larger can? Well, look at this here. The volume of the smaller can is 3 pi and the volume of the larger can is 24 pi. So basically I want to figure out how do I get from 3 to 24? How many cans would that take? So 24 divided by 3 tells me I would need 8 cans. Okay, so 8 of the smaller cans would fill up one of the larger cans if it's twice as big. Alright, that's your lesson on volume. Best of luck to you on your homework.